And now looking at arc lengths. An arc length is just a part of the outside of a circle. It's this length here. And to find out how much of the circle that is, it's the same ratio or fraction as the angle theta out of 360. So let's say that that angle happened to be 30 degrees. Well, what's 30 out of the total circle? It would be 30 out of 360, which can cancel to 3 over 36, which is about 8.3%, let's say. I mean, it's 8.3 recurring, but that's as a percentage. Which means then that the length of this line is 8.3, roughly 8.3% of the entire circumference. And then to find this length L, you have to do the total circumference, which is 2 pi r, and then multiply it by the fraction, which is theta out of 360. And then that would tell you the length of the line. And you can use the same logic when you're trying to find this thing in areas. So it's still the same fraction, it's theta out of 360, but rather than multiplying it by the length around the outside, you're multiplying it by the total circle area, which is pi r squared. So these two formulae are very, very similar. It's the same fraction, theta out of 360, but you're multiplying it here by the circumference to find the arc length, here by the area to find the sector area, and it's simple as that. And the last part of this is to say, how would you find this area here? Well, this combines everything that we've done in this video so far. It finds the total sector area, and then it subtracts this triangle. And from earlier, the area of this triangle was half AB sine C. I'll write that down. Half AB sine C. And that was the area of this triangle here. So then to find the area of the segment is the area of the sector, which is over here, theta over 360 times pi r squared. And then you have to take away the triangle, which is a half AB sine C. And A and B are both R. So then that's why it becomes R squared, half R squared sine theta. You don't need to know this formula, but this is just something that you need to use to find the segment area here.